All right. Good afternoon, everyone. Make sure we are live here. Good afternoon, everyone. Just going to leave this up for a couple of minutes. This is what I'll be doing today. And to be honest with you, this is the elephant toothpaste experiment, and these are the ingredients. I recognize most people probably don't have this combination of ingredients, but I will do this demonstration at the end because it should be exciting if it works. But I'm also doing a making gas, doing that demonstration, and you can probably follow along with that. For that one, you're going to need 1/2 cup of vinegar, about 4 tablespoons of baking soda, and an empty bottle. And I'm going to be using a balloon also, and I'll explain why you will need that as we get going. And so again, the making gas, we're talking about vinegar, baking soda, an empty bottle, and if you have one, a balloon. And so that's what we'll be using to do that one, and we'll be doing that demonstration first. The second demonstration, I'm just doing it for fun. It's been a good 2 weeks, and I really want everyone to I want us to finish out this 2 weeks with a really cool and visually impressive, I hope, experiment. So I'm going to wait another minute and a half or so for people to sign in, and then we'll get going. Good afternoon, Stargels. How are you? Good to see you. I see. I have some friends there on Instagram. Good to see you. All righty. Pardon me. We'll go ahead and get started. And we'll start with the same questions that we've been asking every lesson. So this is lesson 10. And every lesson I ask the same question. Do you know what I always ask? I always ask, what is the most important thing for a scientist to pay attention to when they do an experiment or a reaction? The most important thing is safety. I always want to be safe. Why? I don't want to harm myself, and I don't want to harm other people, and I don't want to break equipment or destroy resources. I always want to be safe whenever I do an experiment. And how do I stay safe? For me, as a chemist, when I go into the laboratory, I always have on eye protection, like safety glasses or splash goggles. I also wear gloves on my hands, and then I wear a lab coat so chemicals don't splash onto my body or onto my clothing. So I always want to pay attention to safety. That is the most important thing. And now, the other thing I have mentioned every lesson. What is it that you should bring with you when you go to a lab? Well, when you do your experiment, you definitely need to bring your lab notebook. You have your notebook today. All right. Are you taking notes? What are the kinds of things that we write in our notebook? Do you remember? Well, I'm always looking to write what I'm doing that day, what I will need in order to execute whatever experiment I'm doing that day. And then I have a question that I'm trying to answer. That question, I write that down, and then I also write down what I think the outcome of my experiment will be. What will the outcome be? Well, I think based on what I have read or what I have seen and what I have studied, that this will be the outcome. All right, that is our hypothesis. So you remember on day one, we discussed the hypothesis. Well, the hypothesis is the critical aspect of research. I need to have some idea of what I think the outcome will be. A hypothesis, if you'll recall, is an idea or a guess you can test. And I really hope that through all these 10 lessons that you've gotten that. So, because today is the end of the 2 weeks that I said we'd be doing these experiments, I did just want to thank a couple people. So I have some people here with me who I want to thank. He's here. Come here.
She's looking at you.
So I want to thank
Hi, family.
I want to thank my wife. This is my wife, and the advertisements that you had with on Instagram and on Facebook and on Twitter that you saw, she actually put those together, and I thank her for doing that for me. She also bought the ring light that is lighting this room right here. She bought that for me so I could do these types of live streams. And this little one right here will be 5 months old tomorrow and bring so much joy to both of us.
Little Miss Valentina.
So
I've been keeping her busy while Daddy is doing his
yeah,
thing.
you didn't know, but she was off camera the other day and she started to make some noise, and so Mommy quieted her down. And who knows, one day she might be a scientist too. So I do just wanted to thank them. Thank you, wife. My wife. This is my wife, Sarita. And I do thank you for helping me. Her handwriting is the handwriting that looks better on the marker board. The other handwriting is mine. And so she's been writing and doing all these things behind the scene for each lesson. And so I do thank her, and I thank my little one here. And I did want to introduce you all to them. All right.
Decir hola. Dile hola. Dile hola. Okay.
All right.
Seguimos.
So today we are going to do, our topic is going to be making gas. Making gas. All right. So I'm going to do 2 demonstrations. The first one you probably would be able to follow along with. Again, you only need vinegar, baking soda, and an empty bottle. I also have a balloon that I'm going to use with it. And we're going to be making gas, and specifically, we're going to be making carbon dioxide gas. And typically, I ask a lot of questions to get you to think about what it is you're doing. So I'll try to ask a few, but I might not ask as many today because I got 2 experiments. I want to get through both of them. And I really want you to see the second one because it should be pretty fun. But the first experiment will be making gas, and we will be using baking soda. And baking soda is actually a type of salt, sodium bicarbonate. Now, that is a different type of salt than the one you eat at the dinner table. That would be sodium chloride. Sodium bicarbonate, when it mixes with vinegar, a reaction happens. That reaction forms carbonic acid. Now, if you ever looked at a soda bottle, you might see this term carbonic acid. It is H2CO3. That is chemistry speak for carbonic acid. Carbonic acid undergoes a spontaneous reaction where it separates out into water and carbon dioxide. And so today we're going to see if we can trap the gas part. I see you, Sid. Bailey's in the house. So here is a question. Do you recall yesterday we worked with oobleck? And oobleck is a fluid or a liquid. And we discussed the 3 states of matter. We said that oobleck behaves like a liquid when it's at rest. But if you add a stress, like you pat it in your hand, it behaves like a solid. So we have solid is a state of matter. We have liquid as a state of matter. The 3rd state of matter, what is that? All right, it's gas. Gas is the 3rd state of matter. What's the difference? A solid, like this marker, maintains its shape. So if I take the solid and put it in this cup, it does not change its shape. A liquid will actually fill into the cup and take the shape of the container that it's in. A gas, however, a gas will fill all of the space that is available to it. All right, and today we're going to make some gas, and we're going to confine the gas to a small area so that we can trap it, because again, it will take up all of the available space. So if you want to follow along, here's what you'll need to do. I have here my glass, and you're going to need a half a cup of vinegar. So I have my measuring cups here. And I actually have a funnel. And I'm going to take my vinegar. Oh, by the way, in terms of safety, this experiment or this demonstration is quite safe. You don't have to worry about it harming you. However, I am using vinegar and there is a splash potential. All right, so I will put on my splash goggles. It's probably not necessary, but I do want you just to understand that safety is important. So I'm going to put them on so you can see me at work here. I have my vinegar. I need just half a cup. All right. And I have a funnel here. And I'm going to place my vinegar in the container. All right. Now, vinegar is actually diluted acid. The specific acid is called acetic acid. That word acetic, if you want to look it up, it's spelled A-C-E-T-I-C. Again, acetic is spelled A-C-E-T-I-C. And acetic acid actually mixes with or has a reaction with sodium bicarbonate. So this is my baking soda. Now here's a cool thing I'm going to do. If you do not have a balloon, I would highly recommend doing the reaction inside of a bowl. Meaning, if you have the empty container, you put your empty container in the bowl, and then you'll add your baking soda in a little bit. But I am going to take a balloon. All right, and I'm actually going to put it on this funnel, and then I'm going to pour some baking soda into the balloon using the funnel. And if you're doing this at home, you'll need about 4 tablespoons of the baking soda. Now, I'm going to eyeball it because I've done this a few times, so to save time, I'm just going to eyeball how much I think I need. All right, a little more. We want this to look pretty spectacular. All right. You know, just for fun, I am going to take the vinegar and I'm going to dye it. Why not? Let's make the vinegar green. All right, this is a stirring rod. It's a piece of glass that chemists use to stir up reactions like you just saw me do. I stirred that mixture there using the stirring rod, so it makes things easier. You might have a spoon or something, a knife that you want to use. Okay, so I now have this balloon. Now here's the key portion. I have my baking soda here. I have my vinegar inside this container. I am going to put the mouth of the balloon on the mouth of the container, all right? But when I do this, I'm careful to not tip the balloon right side up just yet, all right? Because we are getting ready for our big reveal here. Recall that I said a gas will fill all the space that is available to it. It will fill all the space that is available to it, all right? So here's your question. What is going to happen when I take the tip of this balloon and I turn it right side up? Recall, I have baking soda in here, I have vinegar in here, And I said when those two get together, they form carbonic acid. And then I said the carbonic acid spontaneously breaks up into two compounds. One is carbon dioxide, which is a gas. One is H2O, which is water. So what do you think is going to happen? Well, let's find out. Oh boy. All righty. Did you see that? So the gas was confined to the space within this glass bottle and within this balloon. That's all the available space it has. And therefore, it's trapped inside. So inside this balloon now, I have carbon dioxide gas, and I'm able to trap it. Now, if you tried this at home and you didn't have a balloon, again, I'd recommend doing this inside of a larger container, because what will happen is all that fizz that you saw rise to the top is going to pour over the edge of your container. You want to be able to confine it. But the gas would just release into the air, and you just add carbon dioxide into the air. So pretty cool. A couple things happen here. You actually created a gas, all right? You created a gas. So before you put the the baking soda with the vinegar, before you put those together, the carbon dioxide gas that you created had not formed yet. But now you formed it. I think that's pretty cool. One of the things I love about being a chemist is I get to create things that have never been created before in the history of the planet. So you just made some new carbon dioxide. Pretty cool, right? Okay. By the way, you can just take this off, or you can leave it. I probably should have just left it. There you go. That is our first demo for the day. This second one, you can follow along. Again, these are the items that you'll need, and I'll tell you how much of each you'll need. But this one is a little more involved, and each day I have stressed safety. I've stressed safety, and I will tell you, I am using peroxide in this experiment. If you have peroxide at home that's over the counter, it is a concentration of 3%. And that's good enough to do things like clean the wax out of your ears. And that's fine. It won't harm you. But I'm going to be using 12% peroxide. And peroxide, at a certain point, it gets a little dangerous to handle. So I will be wearing my splash goggles. I'm also going to go put on my lab coat. So pardon me as I do that. All right. You thought my lab coat was going to be white, didn't you? Well, I do wear white lab coats often, most of the time when I'm in the lab. But we also have these really cool blue ones, and they're like flame retardant, and it's pretty nice. So I am going to be using 12% peroxide. 12% peroxide is pretty strong, so this reaction should be pretty impressive. I tried this earlier today. I got it to work, and we will see if it works again, all right, on the live stream, of course. So what are we going to use in order to get this reaction to go forward? This is called the elephant toothpaste demonstration, and hopefully if the reaction goes as planned, you'll see why they call it the elephant toothpaste demonstration. But the first thing I'm going to do is I'm going to take this stuff. This is yeast, all right? Now, yeast, we know from making bread. If you make bread, you use yeast, okay? Well, the yeast causes the dough to rise. Why? Yeast is they're actually living organisms, single-celled living organisms, and they're seeking something. And when they get excited, they cause things to rise. In this case, they will be seeking oxygen, okay? Where are they getting their oxygen from? The peroxide. Peroxide has a formula of H2O2. That sounds similar to water, which is H2O. But in peroxide, there's an extra oxygen. And because of that extra oxygen, these yeast want oxygen because they want to live, and they're able to pull oxygen away from the peroxide. Now, when they do that, they get really excited, and so they start moving around, and they cause a lot of agitation. And you're going to see I'm going to add soap to my container. And because the yeast are moving around and there's soap present, I'm going to make some soap foam. It's like if you were playing in the kitchen sink with water and soap with hot water. But that's the explanation. Let's get the demonstration done. Here I have another container. I have my yeast. First thing I want to do is make my yeast happy. The way I do that is I take 1 teaspoon of yeast. I put them in my container here. And next thing I'm going to do is I need to go get 2 tablespoons of warm water. Now, you don't want the water to be cold. You don't want it to be too hot. Yeast, again, are living, and so they want to be in comfortable conditions. So I'm going to get 2 tablespoons of warm water to help make my yeast happy. Pardon me as I get my water. Now, this is going to take maybe about 60 seconds to do, but I need to stir the yeast around in this warm water for a little bit, because if I don't, then they won't be happy, and they need to be happy in order for this reaction to work. So I'm just going to stir these guys up. It's going to take a little while. Also, you can tell when yeast get happy because they don't smell very good. So I'm waiting for this to smell not so great. And again, I'm using a stirring rod. Makes it easier. You can probably use, if you are able to follow along at home, you could use a spoon to stir your yeast up. Okay, we are getting there. We're getting there. I'm starting to smell them. Yep. Getting there. Getting there. I have years of experience in the kitchen growing up, cooking with my mother, so I'm used to a process like this. By the way, chemists often make good cooks because we have all kinds of recipes that we call reactions that we're doing all the time. Alrighty. I think these yeast are happy. Now, I am going to take half a cup of 12% peroxide and place it in this container. This is the container that my reaction is going to occur in. Here is my 12% peroxide. Believe it or not, my secret to this is actually bleach for hair. So if you go to Sally's beauty salon, this is where I bought this at. And really, when they're bleaching your hair, they're putting peroxide in your hair. All right. That's your fun fact for the day. Since this is the last day of these 2-week lessons, I'll add another fun fact. I had a wild phase in my life. I used some stuff like this on my hair. First time I used it, it kind of turned orange. Second time I used it, it got more bright color, it looked golden. Fun times. All right, so I am going to get half a cup of H2O2 peroxide, and I'm going to put it in this container here. All right, and I'm going to go grab another funnel. I want to use the same funnel that I used for the baking soda. All right. That's a quarter of a cup, so I need to add a little more. All right. So I am through using the peroxide, and I'm always glad when I'm done using peroxide because peroxide can be dangerous. So I'm all finished with the peroxide. I have peroxide here. I have my happy yeast here, but how am I going to get this stuff to foam? Well, I need dish soap. So you need to add just about a teaspoon of dish soap. Again, I'm just going to eyeball it because I've done this a few times, so make this kind of fun here. That should be more than enough. Now, I want this stuff to look like toothpaste. So I'm going to take some red food coloring. All right. Now, the key to this is going to be a couple things. This is going to happen really fast and it's going to go all over the place. So I do now want to use my bowl. And I'm going to try to situate the camera in such a way that you can see what happens. And all right. Can we see it if we're on Instagram? Oh, we can see it just fine. All right. Are you all excited? Are you excited? If this works, it should be exciting. Make sure my yeast are okay. I think my yeast are okay. All right. Oh boy. Gonna give this a shot. One thing about chemistry and doing reactions is you never know if it actually is going to work until you try it. So here we go. There we go. Now do you see why they call it elephant toothpaste? Kind of looks like toothpaste coming out of a bottle. I'm so glad I got that to work live. I'm always nervous that it won't work live. Okay, so what has happened here? As I mentioned before, the yeast are moving around really, really fast because they're really excited because they have food to eat. So they do the same thing that you do when you get food. You're like super excited, you're full of energy. Well, because I put the dish soap in there, what happens is the activity of the yeast causes the dish soap to foam. And because it's in a confined space like this container, and I was using a pretty high strength of peroxide, it happened really fast and it forced everything up and out of the bottle. All right. So there is our reaction. This is our elephant toothpaste. And again, we're making gas in that reaction as well. And I do just want to take a few moments to say a few things. I want to say thank you to everyone for the last 2 weeks. I realize that these are tough times for everyone. And I figured I could do something for the parents and for the students and the children from my skill set and from my ability. I really sincerely hope that you've enjoyed these lessons. You can find them. You can find most of the things we've done in the last 10 days. I already have posted on my YouTube channel. You can find me on YouTube by going to Dr. Boyd the Chemist. Just search YouTube for Dr. Boyd the Chemist. Subscribe to the channel. If you want to repeat these experiments, I'm actually going to post each day. I'll post all 10 of the lessons there on my YouTube channel, so you can go back and review these live lessons. The quality won't be great because it's coming from my computer camera, but they'll be present there. And of course, you can see the library of other experiments and demonstrations that I've done. And I constantly post more and more videos. I also want to say that I am a person of faith. Even though I'm a scientist, I do have faith, and I sincerely am praying for the world and for this country to be comforted during this time and to heal. And I'm looking forward to us coming out of this well, and certainly praying for all of you. Again, thank you so much for joining me for all of these experiments. I hope you gained something from them. I hope you learned something, and I hope that I have helped. All right. This is Dr. Boyd signing off. Take care. God bless.